if you're being asked to find the domain of a function like this, or what if you were just being asked to decide, is this thing in front of you right now a function? Well, how do you know if it's a function? You want to make sure it meets the criteria for a function. Does this look like it is a function? Yeah, it doesn't look like any x value is being used more than once. Here, I passed the vertical line test. It's not being used here. It is being used here. Okay, then I am being, all x values are being used up over here. All these x values on the x-axis have a job. They're right there, okay? That's being used. This is not being used. All of these x values are being used. These are the x values. They're being used right over here. Not being used. Asymptote, it's not being used. This dotted line's a guide telling us where to expect my graph drawing to be, all right? The dotted line is just a guide to help you make your graph. So my rest of my graph over here also passes the vertical line test, right? So if I have to do the domain, which way do you describe domain? From where to where? From left to right. So if I look at this from left to right, even if you're not being used in one place, are you being used in another part of that graph? So just to kind of highlight the colors a little bit more, here it is being used, right? These are big open circles. A lot of people are completely skipping over the big open circle aspect of it, and they're kind of like thinking it is included, thinking it's not included. This is being used, right? Not being used. Open circle, all of this is being used. Really, this whole graph could be the same size as the dot. We just draw it skinny because of the things we use to draw our images. All right, here, I'm just making it thicker because I'm going to cut this up in a second to kind of point out some stuff where I think people are having a big mental block. And then there's that other green dot over here, whatever color. So now it's purple. Okay, this is still a graph. It's just a random dot, but it's still a part of the graph, okay? If you're dealing, and we said, yes, this is a function, okay? If we are doing the domain of this, what happens? When do you use a union symbol? When do you not use a union symbol? It's confusing, right? So basically what you have to look at, I'm being a little weird here, but I'm going to cut this up everywhere I have these breaks. I'm going to cut it, cut it, cut it, okay? So I'm just going to cut the bottom off so you can kind of see it all happening on here, okay? I'm going to cut this here because this seems to be an area of concern. I want to know, what's my domain? Is this being used? Is this not being used? What's going on? Then over here, this is another place where there seems to be a jump, right? Oh my gosh, I can't make it straight. So I have that over here. Then this is another spot where I seem to be having a jump in my graph, a little bit of a break happening. It's right over there, okay? So this was my graph, my domain. Was I good over here with domain? Everything was fine, but then this happened, right? I'm even going to cut off this little dot guy that was over here. I know it said function yes or no, but okay. The pink is fine. The pink was all the graph. Everything was wonderful. The green, I'm only looking at the x value, so it doesn't really matter if you move it up or down. This open dot and that open dot can line up, right? But this random point could fill in the hole, okay? The random point is essentially filling in the hole. So it's every x value being used so far. Yes, nothing's being left out. I do not need a union symbol right now. Question?
So if, let's say like the green and the pink, and like they were both open circles, if they are there, and it was that like not the dot, it would be.
Yeah, but I have this random dot, so it does like, it's sort of like, you ever use spackle to patch up a hole, like if your parents ever did like construction on the house? So it's almost like, here, I had this hole in the wall, but I'm going to put spackle on it and it fills in the hole. Now the hole's filled. Now the green graph is done, and now this other graph starts, but it was colored in because of the green, right? I know it's not colored in with this like reddish color, but it's still filled in for the green, so we're good. It can't be filled in for both or it won't be a function. Here though, in this orange graph, is this x value being filled up and used? No, because I have a dotted asymptote, which I never touch, and an open circle, which I never touch. So where does the union symbol get used? Let's see, from negative infinity, I'm good. I'm good, I'm good, I'm good, I'm good, until 0. When am I not good? 1 is still good. It's colored in for the green. 2, 3, 4, 5, 6. Really looks like the only issue we have is 6. So 6 would not be included. So what would I write for my domain? Domain from negative infinity until 6 with a union, and then 6 until infinity, right? And that's really the end of it, okay? So that's all it really comes down to. Now, the other way I was sort of describing graphs like this, I'm just going to kind of put this back together the original way, right? The other way I was describing these graphs, I gave this little comparison where I was talking about crayons melting, right? If that analogy, okay, I'm checking domain, everything in pink over here melts. I have this folded along this crease. Everything melts, all this crayon, pink crayon melted into this area. Do you see? This is the crease. That's where the pink crayon melts. Where does the green crayon melt? Everything along next to it. Everything along next to it. There's a little bit of a gap somewhere. It's folded here. This is the crease, okay? So how is it folded? I'm going to take this and show you. It would be folded, so everyone's going to visualize things differently. Sort of like here. Do you see I just folded it along the axis? So it's this axis is where it folds. I put it out in the sun, and now it's melting. All of the orange starts to melt. What orange is melting? All of this melts, goes down in there. All of this melts, goes down in there. So what's colored orange? Everything except where the asymptote is, right? This color's forever. It just melts into the crease. That's where it goes. The x-axis is being used in all of those places. It melted in. And then this one right there, same idea, melted in. The ends were not colored, but all this got melted down. It dripped down, okay? See, this is it dripping and melting. This is what wax does, right? Melted down, and now it's in that crease there. That x-axis is being used. That's why I showed you graphing on a number line first. You're thinking of it as a number line. Everything on the number line is colored, except there's a gap here, not colored. No crayon has to melt into that spot over there. That all melted green, that all melted pink, so the only spot that wouldn't get anything on it would be that part. So it's up to you which way you want to look at it and kind of get an understanding of it. So that's just one example. So again, it's similar to the answer key. So this is like number 2 was an example like that, okay? And number 10 was an example like that. So could I pick this dot up and slide it and fill in that hole? Yeah. Can I pick this dot up, slide it, and fill in that hole? Can I slide this part down and just line it up with that? So am I changing my x values by sliding something up and down? No. Up and down, I'm messing with my y values. But my domain's not changing, okay? So the only thing that I don't have x value for is right here at 2. That's the only one I don't have any x value assigned to it. 2 is not being used, it's just an opening. That's the one I need a union for. Oh, am I cut out? Did you see it? Was I pointing at it? It wasn't on the screen? Or was it on the screen? Hello? Was this showing on the screen just now? Oh, that's what I was asking. Because I didn't know if I pushed it off. Here, same thing. I could slide them and line them up, but I will just have 2 open circles, right? So that and that will just be all messed up. For this one? Just like, even the one, how about the one I just made up? So this messy one, right? I'm going to slide it back together again.
And that just be 2 infinities.
Why would it be 2 infinities? A negative infinity to positive infinity? I don't disagree with you. Which part of it? Yeah. Right. The orange point's all the way down and all the way up. So negative infinity to positive infinity. But what if this part was not there, right? Let's take it out. Now I only have this part. So positive 1 until infinity. Y1. So if you look at the y-axis, what's the lowest part of the graph we have is right here. The smallest y value we have is 1. Is 1 included? Yes. And then does it go up forever after that? Yes. Okay. Well, what if this is not included? Now it's just these 2 pieces. The lowest part looks like, yeah. The lowest part looks like positive 2. Is 2 included? Uh-huh. And then that looks like it's what? 3, 4, 5, 6, 7, 8. And it's not included. So then that would be from 2 with a bracket to 8 with a parenthesis. Is this clicking? Does these little puzzle pieces help, kind of? We could build our own function, like put it together in our own way. Now it's here.
You mentioned something about 2 filling spaces, and you said that wasn't a function.
Right. If it was like, so for example, if this part here with the pink and the green, right? If these were both colored in, would it pass the vertical line test? No, it fails because if I draw a vertical line here, I touch the graph in 2 places. These open circles means that there's no graph there. So then I'm not failing the vertical line test because I can only touch it no more than 1 time. I'm touching it 0 times unless. So if there was 2 points colored in, it would not be a function.
Basically, they only can link up if there's an only white circle and black circle.
Well, then the domain would be continuous. The domain would be straight through, fluid, right? Like someone was like singing the song, they ran out of breath, and then someone else started singing the song.
What if they were too close? Would they still be not?
That's what we're saying. If it's too close, it fails the vertical line test. It's not a function. Okay? Question.
Wait, so then why for number 2 is it a function?
Number 2, do you have 2 closed circles? If only if you have 2 closed circles, colored in.
They're open.
Right. So they're both open. So to fail the vertical line test, you cannot touch a graph twice somewhere. I'm not touching it. The circle is marking where I have no graph.
Wait a
So if
minute,
it's
then what about
open,
9?
it's a still function.
So they're both open. It means that the graph's not included there. So that's like me saying, oh, here's your new seating arrangement. You're sitting at that chair, but someone else is sitting at that chair. I can't have 2 people in the same class sitting at the same chair. I can have the chair empty. No one sits there. Fine, right? If no one's sitting there, we're still functioning just fine with no one sitting in the chair. But if I try to sit and then Paige is trying to sit on your lap, you could be like, Paige, I'm trying to learn. Get out of my chair. You're in my seat. You can't both sit in the same chair. So the chair is like the x value. Can I have an empty chair? No one sitting in it? Yes. Could I have 2 people sitting in it? 3 people? No. Okay? So that would be for the graphs there. So like that one, I can't have 2 open. I can have 2 open, it still functions. I could still have 1 open, 1 closed, that's fine. 1 closed, 2 open, fine. Because the open circle is a big mark to mark where you don't have graph. Okay, it's just showing you that you end there, like there's nothing there. Okay, so that's the domain from graphs. The domain of these, we have a bunch of rules in math. One of the rules we have in math is about division. There's a certain number we're not allowed to divide by. Okay, what are we not allowed to divide by? So divide by 0 is not allowed. This would be our symbol, our secret symbol. And when you're not allowed to do something, I guess we do that. Okay? Our symbol, not allowed to divide by 0. That's a big, important thing, right? What do fractions represent? What mathematical operation are fractions? Division. I mean, they even look like division signs, right? Something over something. Wonky division signs. I'm not allowed to divide by 0. Is x plus 5 equal to 0? Does that say 0 for my denominator? No. Is it possible that I accidentally plug a number in here that makes it equal 0? And I don't want to do that, because then that ruins the problem. So instead of writing it equals 0, I'm just going to like lay the law. No, it can't equal 0. Same thing. Well, what number makes it equal 0? Negative 5. That one you could do in your head, but algebraically, what really goes on? You get x alone. That's it. You're solving for what x cannot be. Instead of finding what x is, you're finding what x isn't by just calling it not equal instead of equal. So instead of saying x plus 5 equals 0, I'm going to say x plus 5 can't equal 0. What will make that true? When x is equal to negative 5. So I better lay down the law. X can't equal negative 5.
That's a lot easier.
What can x equal? It can't equal negative 5. What can it equal?
Literally anything else.
Exactly. Every other number. So what are the other numbers? Everything bigger than negative 5 and everything, yeah, negative infinity to negative 5 in parentheses because it's not included. Then union. Beautiful. Best thing I ever saw in my life. That is the domain. Is it clicking a little bit?
Oh yes. Clearly.
Okay. So this one, again, do you see a rational expression here? Do you see a ratio? Right? It's a fraction. Numerator divided by denominator. Big ugly division sign. Am I allowed to divide by every number in the universe? No way. I'm not allowed to divide by what number?
One.
No, I'm not allowed to divide by 0. So you just say the bottom can't equal 0, and then you just get x alone. What do I do to both sides? So x can't equal 1. What can x equal? Everything else, just not 1. Okay? So here's 1. It can equal that. It can be all the other numbers. Now, do you have to like sit here and bust out a highlighter every time? No. You could probably do it in your head after a while, but for now, negative infinity until 1, and then 1 to infinity. So you don't have to guess what number does it. This does it for you. It will find the number. So here, what should I write down to solve this problem? Want to try, Ava? What should we write down? 3x minus 10, good. Can't equal 0, laying down the law. Then, what do I do to both sides? Add 10. So I add 10, then, Logan, what do I do?
Divide by 3.
But 3 we're allowed to divide by because it's not 0. That's why we're allowed to divide by 3. X cannot equal 10/3. Do I care what this is as a decimal? Do I need to make it a mixed number? No, just leave it alone. Could you go right to the domain right from here page? What could we write as the domain? No number line. Yeah, done. So you don't need to write, so that's just the domain again, I should have labeled it. You don't need to draw the number line, but it does, I feel like drawing a number line helps. I've been doing this for a million years and I draw a number line all the time. I just feel like I like to have the picture right above it, so I'm like, these numbers are the ones I'm including. But it's like, don't overcomplicate it. Do you see, it's really not anything. So just as like a bonus, what if I gave an extra credit question, right? I could give you guys extra credit tomorrow. Maybe I give you an example, j of x equals 17x squared minus 3x plus 1,000 all over x squared minus 4.
Wow.
Does the numerator matter?
No.
Anything can go in the numerator. The numerator, we don't care. You can multiply by 0, you can multiply by 10, you can multiply by 2, negative 8. Who cares? The bottom, we can't divide by 0. Now, how many numbers can make this thing equal 0? I have to square something and subtract 4. What number do you think is bad? Okay, I agree. We're going to write this on the side. X can't equal 2. But is, yeah, what about negative 2? What happens when you square negative 2? Right, and it's still going to cause an issue. So most people will skip it because they're rushing, you know? That's why one of the many reasons we learn how to factor. So again, this would be a bonus. It wouldn't be like a regular question. But if I give you a quadratic or something bigger on bottom, you got to factor it to find all the numbers that can make it equal 0. So if I factor this, I just rewrite the top, 17x squared minus 3x plus 100, right? All over. How does the bottom factor? It's the difference of, yeah, and what is the factored form of that?
X plus 2.
Wait, and then x plus 2.
Yeah, good. So now you could see the two numbers that are bad. I could say this can't equal 0, and I could say this can't, because isn't 0 times anything 0? So really, I could be like, all right, x minus 2 is not allowed to equal 0, so x is not allowed to equal 2. Boom, there's one of them. But if that's 0, I still have a problem, right? Because 0 times anything is 0. So x plus 2 also can't equal 0. So x can't equal negative 2. So what can x be? Everyone else. It just can't be those two. So how many union symbols will we have? Right. So on a number line, I might say, here's -2, here's 2, open and open. It can't be those, but it can be all of these, all of these, all of these. So interval notation, again, maybe you guys get a bonus extra credit because you're here for help. What do I write down for my interval, for my domain? Where do I start it? Go ahead. Negative infinity until? To -2, good. Union. -2 to 2, union. Sorry, it's a little crazy looking over there. Okay, kind of see? So it's really less is more. You guys, I think, freak out, and then you like look at it like it's hieroglyphics. You're like, I don't know what I'm looking at, and you freak out. But really, that's all it really comes down to, okay? Just certain number, you can't divide by 0. If you can't divide by 0, don't let it happen. So you just basically make a restriction. You like block off a certain number. You're like, okay, my domain, your domain is the X values you're allowed to deal with, okay? It's like, these are the people you're allowed to be friends with. These are the classes you're allowed to take. If you're a freshman, you can't take driver's ed. I don't know, I'm making something up. I don't know whatever the courses are, right? So it's blocked. You can't pick it when you make your schedule, right? Your domain of classes is these are the ones you're allowed to take. If you didn't take Algebra 2 yet, you can't take pre-calc. If you didn't take geometry, you can't take Algebra 2. You know, like one thing leads to another. So your domain is setting up your restrictions, okay? If you're finding the domain when you're dealing with a radical, a square root in particular, obviously there's a ton of different types of radicals, cube root, fourth root, fifth root. There are radicals in your numerator, radicals in your denominator. There's a lot of things that we can do. We're keeping it pretty basic right now. If I asked you about an equation that had a square root in it, and I asked you for its domain, we did derive the square root of x as a parent function. In the back of the notes packet, we had this example, and we also had this example. And we had, they weren't all f of x, I called them like different letters, but we had absolute value of x, remember? This one made a v. This one made the parabola. What did the square root look like? Do you remember? We filled in different numbers. We plugged in 0, 1, 4, and 9. We made a graph. I said, oh, what happens when you plug in 0? What do you get when you plug 0 into this? What do you get when you plug 0 in for x? F of 0. Yeah, you get 0. So 0, 0 is a point on my graph right there, boom. What do you get when you plug in 1? F of 1. Okay, 1, 1 is a point on my graph. What do you get? And this was in the notes packet, F of 4. You get 2. So over 4, 1, 2, 3, 4, up 2, that's a point on the graph. The next one was F of 9. So if you plug in 9, you get 3. So 5, 6, 7, 8, 9, and up 3. What would be the next number I'd probably ask you to plug in? Right, I'm going to ask you to plug in, nice numbers we could take the square root of easily. Can I take the square root of 2? Well, right, so does the graph make sense? Like, these are just decimal values for my answers, like, whatever, that's just what happens. They're not perfect squares, but I can take their square root. What's the square root of a negative number? We don't have any real answer for that. What number times itself is negative? Well, we can't do that. So if I asked you for the domain of this picture, if I only gave you the picture of this graph, could you tell me the domain of the graph? I feel like you guys have gotten better at that. So if I asked you for the domain of this, what would you tell me? Yeah, it's 0 until infinity. Now, that's from a picture. But what about from the equation itself? We just said you can't take the square root of a negative. So the thing underneath the radical, which is called your radicand, the thing under the radical, which is x, must be not negative. So if you're not negative, what are you? Positive or? Yes, greater than or equal to 0. Well, that's done. I don't even have anything to solve because this example is so little. Greater than or equal to 0. Here's 0. Here's equal to 0. Greater than or equal to 0. Well, here's equal to 0. Here's greater than 0. So don't I get the same domain that I got over here? Yeah. So all that happens when we just change up our square root problems is we just change up this work. So what's the work when you have square root problems? And again, there's a lot of different radical problems that we'll have in the future. We're just doing square root functions for now. When we have a square root function and you're dealing with the domain, okay, it's going to look like f of x equals the square root of, and the thing inside I said is called a radicand. And the rule is your radicand, radicand, has to be what? So greater than? Yes, and then we solve for x, and then that equals your domain.
So, like, for number 2, it's the d of x equals square root of x plus 5.
So I'm going to make it crazier looking. Let's do, who cares what it is, 13x minus 4.
Oh, we can't see it.
Oh, my bad. Thanks. I always do that. 13x minus 4. I wish like laser lights shot out of here with like a square, so I would know what is being picked up, so I could see because I don't look at my screen. So then I end up. That's why in the video, I don't know if you guys can tell. You see how like when I made this video, this is on paper because like I did it off camera. So I edited the video and put a new clip in because I'm a stupid head and I keep doing it off camera and don't realize till I'm editing. So I have a square root function. It's a function because I called it g of x. That means it's a function. And it's a square root function because it's got a big fat square root in it. Done. Again, mathematicians are not creative. They're like the most boring namers of things ever. When you guys get confused, you're like, math is so complex, but it's like they're being so simple. Okay? What's the rule? You cannot take the square root of a negative. So the rule is your radicand, the thing under your radical, because x is a mystery. I don't know what x is going to be. What if I accidentally plug in 1? Will 1 be okay? Let's see. 13 times 1 is 13. Minus 4 is 9. Okay, that's fine. What if I plug in negative 8? Let's go smaller. Negative 2. What's negative 2 times 13? Minus 4. Negative 30. Wrong way. Negative 30. Can I take the square root of that? I just broke the problem. Not good. If I establish my domain first, I don't accidentally plug in anything bad. So, radicand, which is 13x minus 4, must be greater than or equal to 0. Solve for x. What do I do first? 13x is greater than or equal to? Let's even do this. I'm going to make it negative, 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 okay? Greater than or equal to 4. Next step. Divide by negative 13. Nice, we flip the sign. So x is less than or equal to negative 4 over 13. Now that's your domain. Before I write my interval notation, happy person, I'm going to write it down and put it on a number line. Okay, so greater than or equal, less than or equal, which am I going? I'm allowed to equal it. Less than is this way. So what's my domain? Negative infinity. Negative 4 over 13. Oop. My bad. Bracket. Because it's included.
So would it always be like either less than, greater than, or equal to 0? You're setting up those problems.
For an inequality like this that you start with? Yeah, for this kind, yes. But there's, they do boost up later in the year. You'll see like when I have to take the square root. So if I really show you what we're taking the square root of right now, it's going to be a very strange idea. Maybe the visual will help people. I'm going to do like an easy one. Like, okay, h of x, h of x equals the square root of, let's say, 1/2 x minus 3. I know it's a little scary because there's a fraction in there. I'm trying to take the square root of what kind of equation? What kind of equation's inside there? Yeah. If I try to take the square root of a linear equation, the linear equation is really its outputs. The answers are what define it. Minus 3, I start here, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Am I cut off? No, I'm on, right? This is the line, right? My slope was 1/2, up 1 over 2. My y-intercept is negative 3. Okay, I'm trying to take the square root of this thing. Here's my square root symbol. I'm trying to take the square root of it. That's the equation, but every equation has a matching G-word graph. So I'm trying to take the square root of that graph. That looks a little nuts, but this is like, you know, like little kid books have pictures in them. So it's sort of like picture book status of what's going on. So it's like when you see the equation, take the square root of an equation, it's like neat and compact. But now I'm like, okay, we're going to take the square root of the line. Where's the line? Right here, right? I'm only allowed to take the square root of what kind of an answer? Or what kind of a number? Positives or 0. I'm only allowed to take the square root of positives or 0. So this thing has to be greater than or equal to 0. Where is the line? Where is the line equal to 0? The line isn't at the origin though. The line is its y value. So when is the line's y value 0?
3.
There. The line is its y values. The line equals 1. The line equals 2. The line equals 3. The line equals negative 1. The line equals negative 2. The line equals negative 3. But I need it to be equal to 0, which is there, or greater. Which part of the line can I take the square root of?
3.
Only that spot? 3, 4, well, that's like, it's not 3. This is 1, 2, 3, 4, 5. What is this? That's 6.
6 infinity.
Okay? So where's the positive? All this. Visually, it's a little weird now. Sometimes visually it's easier. If I did this one by hand, what's the rule? 1/2 x minus 3 greater than or equal to 0. Add 3 to the other side. 1/2 x greater than or equal to. Okay, here's a big help for you guys because you guys keep messing this up. What do I do next?
Oh,
Sure, we can multiply by the reciprocal. Oof.
Or
Yeah, but you guys make a mess when you do that.
Multiplied by 2 on both sides.
Sure. Okay, we have options. Some of you are going like this, but then you're going like this. You're breaking my heart. Like my heart hurts. This is, no. Broken heart. I can't do one thing on one side and one thing on another, okay? That is bad news bears. So that's not allowed, okay? I have whiteout, but maybe not anymore. So that's out of the question. If I divide one side by a half, I have to divide the other by a half. But why are you going to like make a fraction more fractiony? You guys don't even like fractions. What are you doing? So I heard a couple options. Yeah, you could change it to a decimal, but guess what? Decimal's still a fraction. So when you go divide by 0.5, if I asked you what's 10 divided by 0.5, of course you're going to tell me it's 5, but it's not. It's 20. Who said 20? Good girl. Because when you multiply it by 0.5, you find half of it. When you divide by 2, you find half of it. Divide by 0.5. 10 divided by a half is the same as 10 times 2. So when you said multiply both sides by 2, that was music to my ears. Beautiful, do that. You guys keep messing these up, and then you're doubling, and you should be cutting in half, or you're cutting in half, and you should be doubling. So if I multiply by 2, what's half of 2? It cancels, it's 1. Gone. So is x alone?
Yes.
Yeah, just x and 1, right? And then what's 3 times 2? 6. X is greater than or equal to 6, aka 6 until infinity. Visually, 6 until infinity. I can take the square root. So like, algebraically, graphically, they're really the same thing. But where does it get hairy? You know those graphs I drew? I said we start waving like this. We need to know, when is it above or below the x-axis? It gets a little hairy. Question on this?
So if the 1/2 x was like 1/4 x, would you multiply both sides by 4?
Yep. Because think of it, if you have quarters of something, if you multiply by 4, now you have a whole something. You know? If it was 3/4, you can multiply by 4 first, and then divide by 3 to get rid of it. You could do 4/3, but then people make a mess on other things when they try to clear out their fractions, so it's the only reason I'm not saying that, but you can. Question?
Oh, I took the deduction just now. Over.
Yeah, sure. So what's the next one we want to go over? All right, so if we were given something like this and we were asked to expand, there's a good way to do this problem and a bad way to do this problem. Let's talk about the bad way first. Bad doesn't mean wrong. Bad just means harder, more difficult, more work. But we want to think smarter, not harder, but maybe you weren't thinking. So how do you multiply something like this? Well, I'm going to start by multiplying 2 of them. Expand that. So first times first, so I use FOIL to help me out. I get 28x to the second outer plus 32x inner minus 35x last minus 40. I'll clean that up in a second. 7x minus 8 just comes down for the ride. Let's combine like terms. 28x squared, that's going to be minus 3x minus 40 and 7x minus 8. Next step, I'm going to take 7x and I'm going to multiply it by each of these things. So 7 times 28, that's 7 and 4. So 7, 7, 49. 49 times 4, 50 times 4, 200. Take away 4, 196. 196, x to the third. 7 times 3, so minus 21, x to the second. 7 times 40, minus 280, x. Now I'm going to multiply 8 times everything. 8 times 28, well, 8 is doubling it 3 times. 28 goes to 56. 112, 224. So minus 224x squared, I'm going to put it under this other x squared. 8 times 3, negative times negative, plus 24x. Negative and negative is positive. 8 and 40 is 320. Do you see my system, what I'm doing to keep it organized? And if you kind of heard what I said while I was doing these, like when I did 28 times 7 in my head, do you see I have no side work? But you guys are doing like a lot. Think smarter, not harder. 28 times 7, when I did this number in my head, I did, so 7 times 4 is 28 in my head, and another 7. 7 times 7 I did first. That's 49. 49 times 4, I did in my head. 50 times 4. Play this back later. I promise this is what I said out loud, quickly mumbling to myself like a lunatic. Well, that's 200, but I'm 1 short. So take away 4. That's 196. So like, keep practicing these things. Don't wait till the test to practice, but like in class, on examples, in homework, wherever. Always practice tricks to make your life easier. Now I have 196 x to the third. This is minus 245 x squared, because they're both negative, so I add them with negatives. Negative 280 plus 24 is the same as 280 minus 24. 280 minus 20 is 260. Minus 4 more, 256, but it's negative. So there, plus 320. Now, that was the bad way. What a nightmare. So messy. Fine, but messy. Now, the easy way. The easy way would, if you recognize that you have conjugates, these two, multiply them first, because your outer and inner will cancel and you'll have less to deal with. So if I multiply those, I'll have, I'm just going to rewrite 4x minus 5. So this is the good way. 4x minus 5. Now what's 7x plus 8 times 7x minus 8? Well, 7x and 7x is 49. X squared. Outer and inner, gone. They matched. One was positive, one was negative. They're gone. Minus, what's the last term? 64. Now, instead of having 2 terms times 3 terms, I have 2 terms times 2 terms. You could use FOIL. Same thing as multiplying each thing by each thing. 4 times 49, well, that's 196. I just did that a second ago. X to the third. Outer, 64 times 2 is 128, times another 2, 256. Negative. So it's 256x. I'm going to write it here because I don't have an x squared term yet. I might squeeze it there so I don't have to reorder it into order, descending exponential order. So it's first times first. That was outer. Inner, 49 times 5. 50 times 5 is 250. So then it's 245 and negative. 245 x squared. And then last times last, 60 times 5 is 300, right? 4 times 5 is 20. So 500, or not 500, what did I say? 320. Negative and negative is positive. So I could do the good way, okay? Or I could do the bad way. Which one looks like a better amount of, this is still with it, amount of work? The good way, right? So that's just like being strategic and just identifying that you have this. Then something like this, I know the numbers are gross because I picked really big numbers, but this would factor using using grouping, and you would get this back. First, you'd get this. You can't stop. If you see that, keep factoring because that's the difference of, yeah, so just always factor completely. Second. So what can you expect for test questions? First and foremost, you need to show me that you can factor every type of example. So one example, number 1, maybe this section is factor the following completely. Factor the following completely. Now, how do I make up examples? I'm telling you, I do not just write any number down on the paper and hope that it works. I make them up by distributing and multiplying nice numbers. So maybe I want one to be just a classic AC method. If I want it to be AC method, I might multiply out 3x plus 4 and 2x minus 5. I'm going to multiply that out, and you have a question. Here's your first question, say. 6x squared, then this is what? Minus 15 and plus 8x. So what's that equal? Negative 7x and minus 20. Okay, so number 1, I'll rewrite it here. And this isn't exact numbers, but I'm saying very similar to how I make it up test questions. So number 1 looks like that. And then you would have to factor it using AC method, whatever. Another example I could give you, say number 2, another factoring. Maybe I want you to do a greatest common factor problem. So maybe I even combine it with something else. So maybe I take something like 3x to the 4. That's a greatest common factor, right? And now I'm going to give it a little expression over here, like 2x minus 3. Well, what would that look like if I gave it to you? 6x to the 5th minus 9x to the 4th. So that could be a question, right? I make sure I give you like one of each type. Third, maybe I want a difference of 2 squares, but I'm going to throw a little tiny GCF. So maybe my GCF is 2x, but now I need a difference of 2 squares. So what can I give? Maybe I want it to factor to be 5x plus 9, 5x minus 9. What does this multiply out to be? 25 x squared minus how much? Right, because the outer and inner canceled, right? So outer, inner, and then you get minus 81. And all I'm going to do is multiply by 2x, right? So I would give you 50 x to the 3rd minus 162.
So you'd be giving us the
X.
and you have to figure out.
So I'm just showing you, so like I don't just sit down and type random numbers and hope that it factors. I make it factored, I foil it on my scrap paper, and then I type it for a test question. Because otherwise I could give you something that doesn't factor if I'm just like blindly throwing numbers on the paper. Question? I'll give you this. Like the questions, you're not going to see this. All you'll see is anything I put in a box. Factored completely will be there, okay? You will not see this stuff. I did this scrap work to make sure it works. Number 1, that. That's the answer. I made it. When I type it, I give you that. Number 2, I made it. This is part of the answer. I will give you that. And you have to factor it. How do you factor? I just showed you. I just made it. You take out the greatest common factor, okay? I like reverse did it because I can't just blindly throw numbers. Number 3, I won't give you this. You'll see this. So what do you do when you have to factor this one? You take out a greatest common factor. You're going to take out a 2x. You'll have that, and then you'll factor that and get that. Go ahead.
I do it too. Can I see my Google Form?
Yeah, let me just write down one last thing and then, so another type of factoring I can give you, I'm gonna say 4 and 5, so say maybe about 5 examples. We have difference of two squares. We have AC method. We have greatest common factor. I need to sum and difference of cubes. So maybe 512 x plus 343. Now I already jumped to it. I didn't make it up ahead of time because this I could just make up in my head. I don't have to like, really go crazy. Then another kind I like to give, like the super good ones, I think, is something like 8x cubed plus 1. Do you see that's the sum of two cubes? And 4x squared minus 9. I don't know if I did one like this on there. Now, that can factor to difference of two squares, and that's the sum of two cubes. But when I give it to you, it's going to be open all the way. So what does this multiply to? Let's see, 32 x to the 5 minus 72 x to the 3 plus 4x squared and minus 9. I'll give you that. What way are you going to start factoring something like that? Yeah, so you'll use grouping first, underline, underline, whatever, and then you'll get this, but then you keep going. I'm going backwards, so you'll get a binomial and a trinomial, and then here you'll get the two conjugates. So that's how you'll go back. So factor the following, you'll have 5 examples like that, right? Then next section. All right, a 6th question for the assessment. Well, in the study guide, the next thing we really paid attention to were inequalities. I'm probably not going to put a dozen inequalities, but I'll put basically maybe 2 examples, maybe 3 examples. I like the idea of having to divide by a negative. I like the idea of absolute value inequalities. So what would I probably focus on? Let's say if it was 6, 7, and 8, say 3 examples. One of them might be pretty simple. Negative 4x plus 7 is greater than 12. Simple, nice little example. What will the directions be? Solve, find the solution, something along those lines. But it'll also ask you to graph, no y-axis, just an x-axis, okay? It's only x, graph on a number line, graph, and then also the whole point of this, you gotta show that we know how to use interval notation, okay? Solve, find the solution, graph, interval notation, whatever. Even if it never says this, in the rest of your life, please just bust out interval notation. So this one's pretty simple. You'll have to divide by a negative, flip the sign, so don't forget that. If you get a fraction, just leave it. Another kind I'm going to give you, probably a compound inequality. So I'll have something in the middle. Maybe I have 3x minus 2, and it's going to be less than or equal to a certain number, and then greater than a certain number, something like that. So let's say we'll put a 15 over here, and we're going to put a negative 18 over there, whatever, something along those lines. Okay. Next, number 8. I don't know why I put all this space here. Number 8, an absolute value inequality. So, for example, 3 absolute value of 16x minus 12. Well, let's make it 18. 18. No, I used 18. I keep using the same numbers over and over. 11 plus 9 is greater than or equal to 13. All right, so whatever, something along those lines. So we have 3 examples like that. So it's 8 questions so far. What else can I ask? So let's say number 9. What if I give you a set of ordered pairs? 2, negative 3, 4, 8, 7, negative 7, negative 1, 0, 5, and 3, 0. Okay, so I give you a set of ordered pairs, and I ask you, part A, make a mapping diagram. Will you do that correctly? Will you lose points for anything? Part B, make a graph. Part C, is this a function? Something like that. Okay, so there's number 9. Number 10. Number 10, maybe I give you a wild and crazy graph, and I ask you for the domain, I ask you for the range. What could this graph look like? We have a lot of possibilities here, so I'm just going to kind of sketch something out. Maybe it starts off as a closed circle here, open circle there, and maybe an open circle, another open circle, and another open circle. Here we have another asymptote, asymptote. Okay, and then maybe over here, and like that. Could you find the domain? Could you find the range? I kind of even, no, I guess it's fine. Okay, so something along those lines, really any picture, if you and your friends FaceTime each other, draw different graphs for one another, decide, is it a function, is it not a function, what's the domain, what's the range? So you make one up, send it to your friend, try to do the domain and range, they make one up, send it to you, try to find the domain and range, see what you guys get, talk about if you have different answers, okay? So something like that, and I'd ask again for, is it a function? So question A, or 10A, function, domain, C would be, what is the, running out of room, sorry. Range. Okay, obviously we write these with interval notation. And D, maybe I even ask a couple other questions. Maybe I ask you, what's the f of -2? The f of -2. Or I ask you something like, what is the, let's see, what is the f of Okay, so this was 1, 2, 3, 4. What is the f of -4? Or maybe instead of -4, I could also ask what's the f of 3. Okay, what else can I ask you? If f of x equals 1, solve for x. Now, I don't really mean solve for x like algebraically. I would mean from the picture. And I'd have to make sure this picture was really done well. If you wanted to try that one on your own right now, you can, but I'm going to tweak some things because the picture's not great. So if it was like a little bit more like that, okay, I made that purple a little thicker there. And then the pink, let's see, you have this, and let's say right there, okay. And with the red, okay, I'm gonna just kind of make this graph much bigger here, so it's like this. So I'm gonna make it more precise, like it would actually pass through certain points more precisely. So what would the answer to this question be? I'm not going to give you the answer to all of these, but I will talk about this one. So for this one over here, here's 1, when y is 1. This is the y equals 1. The function is its y values. It equals 1. When does this equal 1? That's what we need to figure out. When does the equation equal 1? So I'm just going to grab another piece of paper. If I cover this up a little bit below, here, here, not there, here, and here. Okay, whether you look at it from the bottom or from the top, or if you look at the other way. Okay, there's where y equals 1. The edge of the paper is lined up with it. So where am I looking? Which x values make that happen? -1, 2, 3, 4, -5. There's 1. 4, 3, 2, -2. There's another. And 1, 2, 3, 4, 5, +5. 6, 7, 8, 8. There's another. So it would be clear in a picture. So x equals, and you list the answers separated by a comma. Okay, so I can ask you all sorts of questions like that. All right, so obviously I could ask a lot of other questions for this, but those are some examples. So that's still all one type of question, all mixed up over there. What else can I ask you? I can ask you to evaluate. So this is evaluating, okay? Maybe even one more, let's say. G, what is the f of, f of 4 or something like that. So f of 4, you'd go here, f of -4, 1, 2, 3, -4, you'd be looking over here for the y value. F of, so you're looking for the y value, it just happens to be right under that tick mark. F of -2, -2 is right here. Your answer could be undefined, so keep that in mind. That's a G, not a 9. Okay, evaluating functions, another major area. I'm going to ask you to evaluate a function that has -x² in it, plus say 2x minus x to the third, whatever. And I'm going to say, find f of a negative number. I guarantee it. Oh, sorry, I'm cut off. I guarantee it. Why? Because you guys keep messing this up. I need you to prove to me you can do it. I'm not trying to catch you. Please prove that you can do it now. If you plug in -2, please talk to somebody If you need help with this, okay, I've gone over a bunch of times, you have to put -2 in parentheses. Then you square it, then you multiply by negative. Everywhere you plug it in, you have to use parentheses, okay? Cube means times itself 3 times. Squared means times itself. -2 squared, what does that equal? A number, and then you make it negative. Negative cubed, a negative number cubed means you multiply -2 times -2 times -2, not plus. Slow down, okay? You gotta know your cubes and your squares. Make sure you know these things, okay? I'm gonna ask you to evaluate. Evaluate, okay? I might even ask you to evaluate 2 different functions or a couple different ways. I might say evaluate that. I might say to evaluate something like g of x equals, and I might give you a fraction like, 2x squared plus 5 and 3x minus 7. Find the g of 1. If you get an answer, you have to reduce your answer at the end, okay? So please reduce your answer at the end. And then last in this part might be not just evaluate, but solve. What do I mean by solve? The same thing that we did graphically up here, okay? So still from f of x, okay? F of x equals something. Well, really, I probably wouldn't give you this one. F of x equals 2x plus 17. F of x equals 3. X equals question mark, something along those lines. F of x equals this. F of x equals that. X equals what? Okay? For a second, let's show something. Okay, so I made manipulatives like a lunatic, but if I gave you a problem and I gave you the function f of x and I said f of x equals 3x minus 7. Find x if f of x equals 123. I need you to just think about this using transitive property. F of x equals that, but f of x equals that. Isn't it true that f of x equals f of x? I think so. So won't it be true then that 3x plus minus 7 must equal 123? I also think so. So if f of x is the same, now here you can clearly solve for x. You are not plugging anything in for x in this case, okay? Nowhere did it tell you to plug in 123 for x. That is not what it says. Got it? Got it. Here we have a different example. Here, what if I ask you, here given f of x is 4x squared minus 3x plus 1, f of 5 equals what? Like you're looking for f of 5. This is where you fill in a number for x. F of 5, okay? They want us to find f of 5 given f of x. So what am I going to do right now? All right, I'm going to go ahead and everywhere I have an x, I'm filling in a 5. Everywhere I have an x, I'm filling in a 5. Everywhere I have an x, I'm filling in a 5. So you treat every single x the same way. You fill in a 5 and you will simplify and get an answer, okay? And you just evaluate and you follow the orders of operation rules and you're good to go. However, I could ask instead of finding f of 5, maybe I ask you to find f of -8. So what do? Everywhere you have an x, you fill in -8 to every single spot. You fill it in and you fill it in, okay? So that's the difference. You have to watch this part again, watch this part again. That's what you got to know. That is the difference. That doesn't mean you're done, okay? I didn't finish any of these examples. I set them up for you. So do not leave a problem like this on a test. You simplify, evaluate, you finish everything all the way, all right? All right, now we had 11 questions so far, and we have a few more. 12, 13, 14, and 15. Ooh, sorry, totally not on camera. These are probably going to be something where I'll ask you to find the domain. Yes, you find domain using interval notation, okay? Always, always, always. What kind of equations can I give you? Let's see. F of x equals g of x equals h of x equals n j of x equals. What can they be? F of x, maybe I give you negative 23 over 8x plus 84. There we go, 84. Find the domain of that. What about if I gave you 10x squared, negative 10x squared, plus 27x? Good enough. What if I gave you 118x over 7x plus 22? And then what if I gave you 100 something, 14x, negative 14x, plus 3 underneath the square root. Find the domain, interval notation. There we go. 15 questions. Essentially, that's your test in a nutshell, give or take. Things will be a little changed. Is it going to be these numbers? No. Could it be? Sure, if I get lazy and I decide, yeah, I'm gonna make it these numbers, but guess what? I'm gonna change them. But still, you basically have a practice test. You have a friend, somebody that you can compare answers with, do it, okay? You got this. Follow the study guide, check out the other videos. Instead of watching some other things on your phone, watch the math videos and nerd it up tonight, okay? Good luck.